someone wanted to see as well some of the homework correction. So yeah, that was exercise 28A, the first one that we're going to look at to try and solve here. So whenever you see a vector, you look at the arrow. Okay, so that gives you the direction. So I've got vector from A to B. And in order to go from A to B, I'm going to have to go along the x-axis one way and along the y-axis to get to B. So if I'm looking at this, I'm going, okay, along the x-axis, I need to move 2 steps or 2 units, whatever the unit is. So that'd be 2 for the component vector for x, 1, 2, 3, 4, 5, 6 for y. So you would write the first vector in this format. So we write it vertically. So you've got 2 at the top, which represent the x displacement, and 6 at the bottom, that would be your y displacement. Okay. So rather than being a point that we used to write as a 2, 6 for 1 point in the x and y coordinate, they've just used this form, which is quite similar because you move along the x and you go up on the y. Okay. So if you've got that in your mind, if you were to go from C to D, again, to go to D, you need to move on the right. So whenever you move to the right, it's a positive value. So we've got a positive 1. This time we're going down the way, 6 units. And to represent a movement going down, we use a negative 6. And that's why you've got 1, negative 6. So when you go to the right, it's positive. When you go to the left, it'd be negative. When you go up, positive. When you go down, negative. So if I'm going from E to F, I'm going left this time. So we're going to say negative 1, negative 2. And I'm going up. So that'll be a positive 1, 2, 3, 4, 5. So negative 2 and 5 for EF. GH, so we're going left and down. So left and down is both negative on the X, negative on the Y. So negative 4, negative 2 for GH. Now, if you get a horizontal line or a vertical line, it just means one of the components will have to be 0. So in this case here, which of the two is the 0? You look at, you're leaving from I, you're going towards J. So on the x-axis here, I'm going on the right towards J with 3 units. So that means I've got a value on x of 3. But on the y, I'm not going up or down. So we just stay put. It just means it's 0. So you've got 3, 0 for ij. And for KL, this time I'm not moving on the x-axis to move from K to L. So that means x is going to be 0, or the top value. But I'm going down this time by 4, and going down, we said, was a negative 4. So 0, negative 4. So this is the way you would represent a vector in its component form. Okay. So on the second exercise here, it's a bit doing the work the other way. So we were given the vector, we were asked to find the component form of it. Now we have the component form and we've got to sketch the vectors. Okay, so the first one we're going to sketch is AB. So I'm looking at A and B. So I need to put first my point A. So you decide wherever you want to put A. Okay. Once you've got your point A, you need to use some units. So you can use the square of your grid, for example. So if I need to move 2 on the right and 5 going up, I end up with a vector that looks like this if I'm using this grid. I put A, doesn't matter where it is in the grid. I've used here the top left side of my paper. 2 on the right, 5 up, and that's how you represent AB. Okay? So CD very similar, but it'd be 3 on the right, 4 up. Okay. So you can count 3, 4. EF. So because I'm going to go down by 4, I'm going to decide here to put E top at the right, on the right side. Okay. So I'm going 3 along and 4 down, and that's why you've got E being put at the top here. 3 along on the right and 4 down, and that's how you represent EF. Very similar for GH. So you're going to put G on the top left here, 4 on the right, 5 down. So you can see now how you do that. -2 and 5 up. So you would go -2, 5 up. -3, 2 up. Very similar. Different angle. Now here I've got a -4, -1. So I'm going to go 4 on the left and 1 down. So 4 on the left, 1 down, starting with M going towards N. And the last one, -3, -7. So 3 on the left, 7 down. Okay, so that shouldn't be too complicated. If you can just count from your grid the squares and know where you start and where you finish. That's basically what those vectors are representing here. Okay, so it's a imagine as if you've been asked to move from one point. How do you get to the other point using your grid? Okay. Now here, what have I put is just to show you, for example, if you've got something with X and Y coordinate set this way, and I'm asked to look in, so this wasn't part of your homework, but what I want to represent here is I want to show you what OA, the position vector, we mentioned something about position vector. So what OA would look like. So OA would go from O all the way along to A, right? Oops. So that'd be that vector there. So if I was to write vector OA, that vector would be in component form -3, -2. So -3 and -2. And I can do the same for OB. So if I was to represent OB, it'd be this vector here. And OB would be 2 on the right, so +2. So this is just a bit of practice and revising what we call position vectors. So my computer is completely losing the plot here. Okay, so I said 2 and 5 going up. So those are my component. Okay. So if you're asked to write vector AB, what we looked at last time we did this, we said that vector AB equal B. I know it's just, yeah, I can feel my laptop just not deciding to work. So we said it was B minus A. And why was that B minus A? Because to go from A to B, we need to go opposite OA. So that would be minus OA. So minus OA plus OB. And that's why we said, okay, it's going to be B minus A. So the opposite of OA would be AO. And AO would be minus OA. And to do minus OA, it's a bit like timing OA with -1. So if I had a -3 and a -2, it becomes 3 and 2. Minus OA plus OB. So you'll get 3 plus 2, that'd be 5. So you can see now, to go from A to B, I need 1, 2, 3, 4, 5 on the right. So that's positive 5. So AB can be represented as 5. And from this point here, I need 1, 2, 3, 4, 5, 6, 7. So that's how you would represent AB. It's 5 and 7. And if you were given these points as coordinates, 2, 5 for B, and -3 and -2, you could rewrite your vector AB. Okay? So let's see what we've got next. So that was part of the homework. Yeah. So the homework, sometimes you are given vectors in the component form and you're asked to add them. Okay, so here for A, we're asked to add V plus W. So V plus W, you just add the X, whatever component form, and the Y component form. So that means you get -2 plus 0, which is -2, and 5 add on 2, which is 7. So V plus W would be equal to -2 and 7. So we did X minus W last time. So you just take X, 6, 4, take away 0, 2. You got your 6 minus 0, 4 minus 2, which is 6 and 2. Now, if you do V plus W plus X, we can use V plus W, which is -2 and 7, plus X. So -2 plus 6 would be 4. And 7 plus 4 should be 11. So if this is done properly, it should be 4 and 11. But you can do it that way, -2 plus 0 plus 6, that's 4. 5 plus 2 plus 4, that's 11. So you can add them up like that as well, same thing. Okay, and for the last one, I've got X minus Y minus V. So 6 for the top component. Minus 3, that becomes plus 3. That's 9. Minus 2, it becomes 11 on the top component. And the one at the bottom, you get 4 minus 7, that's 11. Minus 5 should be 6. So that's why you've got it in component form, 11 and 6. Okay. Now we looked at this exercise. So that's where you could be using vectors in real life, for example. So you can have a swimmer being represented by the force he's using to navigate, to swim his way across a river, but the river has got a river flow, a current that can be represented as well by another force going to that direction. So the resultant force would just be the swimmer vector component that you add to the river flow. And we did that and we ended up with -2 and -8. So now if you were to represent -2 and -8, you would go in -2 on the left side and -8 down the way. So that means with these conditions, and if the swimmer is swimming with that type of force, he would just end up at this point here. And you've probably experienced that if you've been into a beach or something, and you've managed to you're trying to swim straight along the line, and you see yourself being deported by the current, and that's all it's been represented. So you end up, no matter how straight you're trying to swim, you will end up in a different place because of the current flow. Okay, so vectors is quite, you know, very much used in anything to do with graphic design or game controlling design, or, you know, whenever you're going to have things moving into planes or into 3 dimensions object. So everything they do by programming these software is using vectors. So they represent the force of moving with vectors. So that's why it's an important part of math learning. It's trying to understand what they represent so that you can program it if you become a programmer one day. Or if you teach, you can explain that to the kids who thinks math is not interesting. They would rather play games and become game designer one day. So there you go. A bit of math will take them some ways. Okay. So the next homework that we had was trying to write down what we call the path. How do you get from one point to another using vectors? Vector path, basically. So we looked at this exercise in detail. And there was another exercise after this one for you guys to have a go at. Was this one, I think, yeah. So we had a trapezium here, U, V, W, and X. And we were told that the trapezium had UV parallel to WX, UV parallel to WX, and XW was equal to 2UV. And what I said to you guys, the first thing you should try and do when you come to that type of exercise is to write down on your paper what you've been given. So we've been told that this UW here, sorry, XW is 2UV. But because UV is H, we just write here 2H. Okay?
2H.
So we've got 2H. I've got K. Now find these vectors in terms of H and K. So we've been asked to find XW in terms of H and K. So XW straight away, I've been told it's 2H because it's 2UV. You just write XW equal 2H. The next one was UW. So UW, to go from U to W, we're going to use this path here. I'm going to go from U to V, which is H, and from V to W, which is K. So because they've asked us to express it in terms of H and K, UW is just H going the same way, positive H plus positive K. So you just write H plus K. Now Vx, in order to go from V to X, I'm going to use a path where I know what I've got. So we said here we had 2H, remember at the top there? So we had 2h. So I'm going to use this pass here from v to w, that's k. And then I'm going to do w to x. So xw is 2h. That means wx is the opposite of 2h. It becomes minus 2h. Okay, so it's the negative version of the 2h, which is minus 2h. So vx is just k minus 2h. Okay, so that's how you would write it. Vx equal k minus 2h. And we've expressed that just the way they've asked us to do. For this time, I'm going to look for ux. I'm going to go from u to v. So ux will walk me from u to v, which is h. Then I'm going to go from v to w, that's plus k. And I'm going to go from w to x. So it doesn't matter which way. In this case here, we've only got one path to follow. And that's going to be minus 2h because I'm going against 2h. So now you're going to treat these vectors as you had algebraic terms. So h take away 2h is negative h. And then plus k, yeah. And that's us. We've written all these vectors using h and k, which is what they had asked us to do. Okay. Now they want us to use some values. So let's say they said h equal 4, 0. So you can see they've used like coordinate 4 along the axis and 0 along the y. So 4, 0, that makes sense. K is 2, so 1, 2, and then 4 up, 1, 2, 3, 4. So now you can see what they mean by component form. They've just represented K, which is that VW, as a 2, 4. Now they've asked us to find the component of XW. So we said XW is 2H. So I just write 2 times 4, 0. So 2 times 4 is 8, 2 times 0 is 0. UW we said was, what was UW? H plus K. So 4 plus 2 is 6, 0 plus 4 is 4. And the last one, UX. UX we said was negative H plus K. So you need to write now negative H plus K in component form. So if I've got 4 here, negative 4 plus 2 becomes negative 2. And 0 plus 4 is just 4. So let's quickly check. UX is negative 2, 1, 2. Going left, 4 up, 1, 2, 3, 4. Makes sense?
Yeah.
So you can quickly check your work by using the table because you know what these numbers represent in terms of real life. Okay, so that's how you would quickly find out if you got these correctly or not, by putting some graduation on your work there. So I've got everything that I need. And what we said is when you've got these bar across the vector, you are looking for what we call the magnitude of the vector. And when we use a triangle shape to represent these 2 and 4 and the vector, we notice that Pythagoras gives us the solution because this side square is just this side square plus this side square. So if you want the side itself, you just square root both sides. So now VW. So did we do VW? So to do, we need to do VW first. VW is K. Yeah. So from V to W is K. And on K, I've got component 2 and 4. So to find VW, the magnitude of VW, you just write its square root of those two components. So the two components I've got is 2 square plus 4 square. So 16 plus 4 is 20. Okay. So
Mhm.
root 20. Now, remember when we did surds? At this level for NAT5, they expect you to give the answer in its simplified, in its simplest form, even if it's not mentioned. So to put the surd square root 20 in its simplest form, we need to find what number can I time that is a square number to get 20.
4 and 5.
Yeah.
4 and 5, sorry.
Yeah, so 4 and 5. What's going on here? I know, it's not stopping anymore. So root 4 times 5, which is just 2 root 5. So that would be your answer, 2 root 5. Okay, and then you would get the mark.
Is my screen gone blue? Gosh,
Not
did you-
slightly.
Ah, see
Yeah.
there.
Better.
So UW,
Sorry.
we looked at UW, what we had, 6 and 4. So we need to do root 6 square plus 4 square, which is 52. And 52 is 4 times 13. And we write in its simplest form 2 root
50.
13. And Vx we said was k minus 2h.
Mhm.
So k is 2, 4, which gives us a component form of 2
40.
minus 8. So that's negative 6. I
Mhm.
don't think we've put it yet. Yeah, so you need to calculate negative 6. And 4 minus 0 is just 4. So you've got negative 6 and 4. So we need to do Vx equals square root of 6 square plus 4 square. It's negative 6 square, but negative 6 square just gives you 6 squares, same, right? Plus 4 square.
Yeah.
Because negative 6 times negative 6 gives you a
6
positive, yeah. 36 plus 16.
52.
Yeah.
52.
Which is just root 52. And because we've already done root 52 somewhere, we're just going to use the same result as 4 times 13, which is 2 root 13.
2 root 13.
And you can quickly check that and say, oh, that we've just found that the magnitude for Vx, so Vx, this magnitude here, yeah, is the same as the magnitude for UW. And that looks correct. Because if you go from V to X here, oops, you get the same value in magnitude between U and W. Because you've got trapezium, remember? So that makes sense. You can quickly say, oh, everything looks okay here, what I've got. Okay. So vectors, not too difficult. You just need to take your time. And the good thing is you've got a quick way to check your work. Okay. So I'm going to pause here because that was the homework done. Oops, sorry. I've stopped sharing, but I needed to pause the video. So I'm going to stop the